Yeah, hello everyone. So today let us discuss one very important concept from mechanics. Okay, so that is like the concept of like springs. So often, like many students will be repeatedly asking me, sir, like when multiple springs are there, we are afraid to solve those type of questions, whether it is in SHM or Newton's laws. So like when multiple springs are given, I want to find the time period. So it is becoming so difficult for me to like follow, sir, whether I should be following force method to find time period or length method to force method to find time period or energy method to find time period. So these are the like questions that I will be receiving from the students. Okay, so today let us see what will be the best method, and let us try to like analyze the complete concept of the springs. Okay, so I hope after like completing this class you will be getting a complete idea like how to approach whenever the spring questions are given. Okay, so let us start with one simple example here. So let's say I'm taking one example. Let's say there is a system like this. And let's say here we are attaching a block of mass m. Now they'll be asking us to find the time period of oscillations, or like maybe they'll be asking you to find in equilibrium, like what is the extension in the spring, so like how much displacement so this block has undergone after, let's say, imagine that we went to some gravity free space. Obviously there won't be any initial extensions in this one, so because no force, right? So if we go to a like gravity free space, anyway no force will be there. Let's say suddenly they are telling that suddenly gravity is switched on. Okay, then immediately this mg force will come, and obviously then because of this force the spring should extend. Let's say they might ask you to find what is the final displacement of the block, let's say after reaching equilibrium, or else from here also they might ask you after applying a force F. Okay, so what will be the displacement of the block because of the external force that I am applying. So these type of questions you might get, or they might ask you to they might ask you to find time period and all this stuff, right? So let us see how to approach this type of question. Let's say for both the springs, spring constant is given as k. Now let us try to take extension in this spring. I am considering it as, let's say, extension in this spring I am considering it as x1, and extension in this spring, let me consider it as what, x2. Now if you see like here in this string and here the force must be same, right? Because it's completely same string. Let me consider here force to be what, F, that is basically tension, and here also the force will be what, F. And here if F force is over here and F force is over here, what will be the force over here? Obviously it will be 2F, right? The force over here will be 2F. So here when I say force here is F, that means the spring force is what, F itself. So because it's an ideal spring, so force must be same everywhere, right? Because it's like it doesn't have any mass. So similarly the 2F will be the force in the entire what, this entire spring, right? So now let me try to find like what will be the equivalent spring constant. When I say equivalent spring constant, what do you mean by equivalent spring constant? That means we need to replace this entire system just with what, one spring and the same block attached over here, we will call this as what, k equivalent. So remember, when I say k equivalent, sir, what is actually k equivalent means? Let's say imagine like I am giving you 250 rupees notes. Okay, then in return what I expect a 100 rupee note, right? So that's like basically I am expecting an equivalent amount return from you. So equivalent means it should be having the same what, same value. So similarly here when I say equivalent spring constant, equivalent resistance and all this stuff, right? So equivalent means, so whatever the effect the original system is creating, whatever the values, okay, of like tension or acceleration, whatever the values that you are getting because of original system, we should get the same values. It might be energy, it might be force, it might be displacement, whatever it is, we should again get the what, same values, even though after replacing the entire system with what, any like a single spring. So that is the meaning of equivalent. That means we should get the same result, okay, same result as the original system. So then only we can call it as what, equivalent. Because otherwise randomly if I want to keep some value, we can just simply randomly keep some value, right? I'll keep 10k, I'll keep 20k, randomly can keep. But that doesn't ensure that we'll get the same result as the what original system. Then you might be asking, sir, what is the necessity of getting this equivalent thing? Because when we have one spring and it is directly connected to block, then we know everything, right? Force is what? Simply kx. Energy is what? Simply half kx square. So only problem for us is when multiple springs are there and they are randomly connected, then that is a problem for us, like in solving like energy or like whatever it is, in finding the force or like equilibrium shift and all this stuff, that will be difficult for us, right? So that means our task will become so easy if we could able to convert this entire system into what single spring system, right? So now let us try to understand how to convert this into a what simple one single spring system. Now here I need to use one more important theorem, that is like what? Superposition theorem. Again you might be thinking, sir, like, sir, what is superposition theorem here? See, this spring will also extend and this spring will also extend. So it will be difficult for me to analyze when both the springs are like what? Working. So that's why first I'll assume that this spring is not moving. I'll assume this as a what? String. And then I'll see if x1 is the extension this one, and I'll see how much the block will move. So obviously when this is not moving and this spring there is an extension of x, let's say newly it got extended by an x1 distance, obviously our block will also move down by how much distance? X1 distance. Now I am writing the distance moved by the block. Okay, so as I said, here I will be using superposition theorem. So when this is like string and this is spring, when this is moved by an x1 distance, obviously our block will also move by how much distance? X1 distance. Okay, sir, this one we understood. Next important thing is, now consider this as what? Now consider this as like a string, and now when this spring gets extended by what? X, then you need to understand here we will get an x length free and here an x length will be freed up. So this x length and this x length, total our block should go by how much distance? 2x distance. Because when the pulley from here it comes over here, this side x length will be freed up and this side x length will be freed up. Now total how much length is, like how much free length is available for the block to move down? 2x length. That's why the block then goes down by what? Double the whatever the amount our pulley has like displaced. So our pulley has, let's say, displaced by an amount of what? x2. Then our block should be displaced by how much distance? 2x2. Our block should be displaced by how much distance? 2x2. Right? So now here this is one, let's say, one equation. Let's keep it aside. Then from here we know, as I said, in this entire spring force is F. I can also write what? F equal to kx1 I can write. This is equation number 2. And similarly in this spring the force is what? 2F. So I can write? 2F I can write it as what? Kx2. This is equation number what? 3. Right? So now, and one more important thing, from here I'll write one more equation, the final equation, because when I say equivalent, okay, so when I say equivalent, as I said, whatever the force that is acting on M earlier, what force is acting on mass M, our block earlier, you can clearly see that F force is acting on our block earlier. That means now also the same force must be acting, then only we call it as equivalent, right? Okay, sir, that's fine. Then one more thing, earlier the total displacement is what? Earlier the total displacement is like x, let's say x block. Now also you should have what? Same displacement. Then for sure I can write the force F will be equal to the K equivalent into what? K equivalent into x block. Why? Because as I said, it should get the what? Same results. Now just by using all these things, now see how we can approach means, let us substitute everything in terms of what? F and K. So x block can be written as what? Therefore, so I am just substituting everything over there. So therefore F by K equivalent, which is equal to x1 is what? X1 is F by K plus 2 times of x2 is what? 2F by K. So this is what we have got. And then so here we can cancel F will get cancelled. So which implies 1 by K equivalent, how much you are getting? 1 by K equivalent, you are getting it as 1 by K plus 4 by K, which is nothing but what? 5 by K. 1 by K plus 4 by K is what? 5 by K. So therefore K equivalent, what is the value of K equivalent I got? K equivalent I got it as what? K by 5. What's the value of K equivalent I got? K by 5. So now once we get the K equivalent value, then whatever things that they'll be asking, then you can easily find, right? Let's say time period of like considering this in like SHM, let's say they're asking what's the time period of this block. Time period of the block is what? 2 pi root m by K equivalent. So just simply substitute this and you'll be getting the time period of whatever the system that they have given. Let's say now they're telling that like multiple things they can ask, as I already said. Let's say they're asking us to find time period. Then simply time period is what? 2 pi root m by K equivalent. Simply. Let's say, or else they're asking us to find, they are telling that an extra force of F naught is applied, then they might be asking you to find what is the shift. Okay, what is the shift in like equilibrium position? What will be the shift in equilibrium position? Earlier our mg force, let's say K equivalent into, let's say x naught is the original displacement, K x naught will be equal to what? Simply mg. But now K equivalent into, because of an extra force that is added, I'll simply write mg plus what? F naught. That's the question, right? They'll be asking when an extra force F naught is applied, then what will be the displacement in the block? So to solve here, it will be very difficult for us, right? Because multiple springs are involved and it's like constrained, completely randomly constrained, right? But after I do this, we are having only one spring. Then it's a very easy task for us, right? So as I ask displacement, then simply I can do what? K equivalent into subtract equation 2 minus subtract equation 1 from equation 2, then what will you get? Simply mg will get cancelled, so F naught. So therefore our shift in the equilibrium position will be equal to what? Delta x equal to F naught by K equivalent. Delta F naught by K equivalent. Okay. So I hope it is clear for everyone how to find this equivalent spring constant by the help of what? By the help of superposition theorem, right? So considering that one spring, okay, as like only like one spring at a time, and all the remaining springs you consider it as a string, and find what displacement you will be having for the block. Okay, what displacement you will be having for the block, and then do the superposition theorem to get what? The entire displacement of the block. But so there is one more easy method, okay, so for like approaching this, that's like then so see, force method means you should be very careful of writing what? Directions and all that stuff, even in SHM also. So you know that like many of us will prefer energy method over force method. Why? Because in force method we should be very careful about directions and all that stuff, because you know force is a what? Vector quantity. But whereas energy, so you'll always prefer to solve the questions by energy method, because energy is a scalar quantity and no need of bothering about directions and all this stuff, right? So here also I'll try to take up the same question, whatever the question I have given here, I'll try to take up the same question, but I try to solve and find the equivalent in a different way and relatively the easiest method and best method also. So I'll try to find the equivalent spring constant. Okay, so how to find the equivalent spring constant means, as I already said, okay, so what is the meaning of equivalent stuff? Equivalent means like all whatever the values, that might be a displacement, that might be energy, or that might be force, everything must be what? Same. So like here I'll use the final point that I have said, okay, that is I'll try to ensure that the energy stored in this system and energy stored in this system will be like what? Equal. Equivalent means energy should be same, force should be same, everything should be same, right? See, this is the beauty in this concept. So easily you will be able to get the equivalent spring constant without any difficulty. So, okay, so see, so I'll tell energy in the original system must be same as what? Energy in the equivalent system. That is the main definition of our equivalent, right? That's the main definition of the equivalent. Sir, how to write energy? Okay, how to write the energy of the system? Here I'll tell one more important thing. Now again, I don't want to involve the expansions, whatever the expansions that is there in each spring. Okay, so like then how to avoid expansions from energy term means we know energy energy stored in a spring formula is what? U, I can write it as what? Half kx square. Okay, what I'll be doing is I'll multiply it and divide it with what? K. Let us multiply it with k and divide it with what? K. So then U can be written as half k square x square by what? Half k square x square by k. Half k square x square by k. But we know already kx is nothing but what? We already know kx is nothing but simply f. So therefore, remember energy we can also remember it in a different form, that is f square by 2k. Energy we can also remember it as what? F square by 2k. So this is the formula that I'll try to use. Why? Because I don't want to involve the displacements over here. Because again, to calculate the displacements and that relation, it will be difficult for me to find if it is moved by a distance x, how much this spring will move, how much this spring will move. It will be difficult for us. Now it might be easy for us because only two springs are there and the system is easy. But let's say when multiple springs are there, I'll take up one question. When multiple springs are there, it will be very difficult for us to like find all that stuff. Okay, that's why I don't want to involve what. But it's very easy for us to find tensions. We know, like whatever might be the system, just all the pulleys will be massless, so we'll use the property of net force equal to 0 and we'll get the tensions, right? And k, like anyway they'll be giving k in the question. So then, sir, what will be the original energy in the system? Original energy will be, there are two springs, so both energy will be stored in what? Both the springs. That means, so for the first, so here you can see 2f force is there, here you can see f force is there. First let me write energy of this one. So f square divided by how much? 2k. F square divided by 2k plus, and the second one, second spring, what is the force? 2f, and so 2f whole square divided by spring constant is what? K itself, which is equal to, now let us come to the energy for the equivalent system. Here, energy for the equivalent system. So coming to the energy for the equivalent system, the same force F should be there, right? Here whatever the force that is acting. Yes sir. Then the same force F square divided by 2 into how much? K equivalent. Then you can clearly see this 2 will get cancelled, and f square and f square will get cancelled. So therefore what we are left out with? 1 by k plus 2 square, 4 by k, which is equal to what? Which is equal to 1 by k equivalent. So from here what will we get? Obviously, like it will be 5 by k. 5 by k equal to 1 by k equivalent. So therefore k equivalent, what's the value of k equivalent I got? K by 5. See, so within like just two steps, just by writing two steps, we are able to get the k equivalent without using any like what superposition theorem or like using any equations, okay, like force equations and all that stuff. Directly we got. And you can see earlier also I got the same answer, and now also I got the same answer, right? We must get the same answer, otherwise obviously one of the methods or both the methods would be like wrong, right? So I hope it's clear for you. So just to make things clear, I'll try to randomly create one more example over here and try to analyze and check whether we are able to do it easily or not. Obviously after knowing this, okay, I hope every one of you can easily like find the equivalent spring constant, and once we can find the equivalent spring constant and convert the system into this manner, as I said, whatever they might be asking, it's like what? Piece of cake, right? So it will be just like easily you can solve whatever the like situation and whatever the scenario that they might be asking. Okay, so as I said, I'll be just randomly creating one situation over here, and let us try to analyze what might happen here. Let's say here one pulley is there. Let's say it is fixed. It's like here rod is there. Here one spring is there. Let's say I randomly created one system like this. Okay, total how many springs are there? 3 springs are there. So let me consider the spring constant of each and everything is what? K, and here also let's say K. And let me take extension, this one is what? X1. Let me take extension, this one as what? X2. And then let me take extension, this one as what? X3. So now we have taken all these spring constants, or like spring constants already given k, and I have taken extensions as x1, x2 and x3. Now first let us try to solve by using what? Energy method. Okay, so let's say the entire equivalent system should be what? It should be replaced with one single spring like this, and it should be connected to our block. Here let me take the force to be what? Let me take the force over here as what? F, and that should be our force on the block. So here also it should be F, and here when it is F, obviously in this spring the force will be how much? So here the force will be what? 2F, and here F, here F, here F, here F. So here also the force will be what, sir? F, right? So then, as I said, energy I'll just equate energy initial equal to what? Energy final. Sir, what will be initial energy? Initial energy is very simple. Just let us write energy of this plus energy of this plus energy of this. What will be the energy of the leftmost thing? F square by 2k plus. Okay, don't think that like every time the k equivalent must be same. Okay, the k equivalents can, every time the k, whatever the k values that I have taken, it should be like same. Even if they can give the different values, then also it's fine. Okay, so you just need to like follow the whatever the method I told. Okay, so just to make it clear, okay, why to take always the equal values? Let me take this as what? This one, let me take it as 2k. Let me take this as 2k, and let me take the third spring as what? 3k. Okay, again you will be thinking that, sir, it is only valid for like equal spring constants. No, it's valid for everything. Then the first energy F square divided by here k equivalent is what? 2k. This is the first spring, and for the top spring it will be like what? 2f whole square divided by 2 into what is the equivalent, like k, that is 3k, plus for the third spring force is f square divided by 2 into what? K, which is equal to the final equivalent, the final energy also for the final system also, the force should be what? F. So because as it's equivalent, whatever the earlier the force is acting on the block, now also the same force should be acting. So that's why it is F force. So F square divided by 2 into what is the spring constant here? K equivalent, obviously. The spring constant is what? K equivalent. So then what you are going to get from here? F square and K will get cancelled. Then here you will get 1 by 4 plus here what will you get? 1, 2 will get cancelled. You will be getting 2 by 3, right? Actually it will be 4 by 6, so it will be 2 by 3 plus, then what will you get from here? 1 by 2, which is equal to 1 by, so k I forgot, k, and then only I have cancelled F square, right? So 1 by 4k, and here 4 by 6, 2 by 3, and here 1 by 2k, and here what is there? F square got cancelled, 2 equivalent, right? So then what is the LCM that I can take from here? I can take 12k LCM. If I take 12k LCM, then what will be there? 3 plus 4 2s are 8 plus 6, which is equal to 1 by 2k equivalent. So then it will be how much? 14, 17, right? So which implies our k equivalent will be equal to how much? So here I can cancel 6 times. So when I cancel 6 times, so it will be what? 6k divided by 17. So this will be our k equivalent. Okay, so this will be our k equivalent for the system. So if you want to just check whether it is right or wrong, so again you can just go back to this method, whatever the method I have told, superposition method and force method. You guys can follow the same method and try to check whether you are getting the same answer or not. Okay, so I hope this concept is pretty much clear for you, how to get the equivalent spring constant by using energy method. So if you know this method, often the many questions in simple harmonic motion and Newton's laws of motion, it will become very easy for you. So whatever the things that they might be asking, it might be like what displacement, or like the force, or like energy, okay, or time period, or like angular frequency or frequency, whatever it is, it will be very easy for us if we could convert the whatever the type of system that they are giving into an equivalent system like this by using the techniques that I have said. Then it will be very easy for you. Okay, so just from the methods, like whatever I told, try to practice at least some 3 4 questions. Try to like analyze on yourself. Okay, so whatever the things that you'll watch, so when you watch the things, or like when you study from a book, it's not only for you, even for me. So you'll feel it's like very like what, you'll be feeling very happy, like knowing some new thing or like stuff like that. So if unless you practice and like realize on your own, obviously remember after some point of time, okay, maybe after 2 days or 3 days 4 days, you're going to forget it. Okay, you're like remember it for a long time only when you can like what, realize on yourself. So for realizing on your own, obviously you need to practice what, you need to practice more and more means like just like till the time you get confidence, maybe you can take up some 3 4 questions, try in both the methods, force method and like energy method. So automatically you'll get a confidence, and that you will get so much confident on this type of models, and you can easily score whenever these type of questions are given in the exam. Okay, so I hope it's clear for you. Okay, thank you, bye bye.